Question 9a. Samples of phenols are reacted separately with sodium and dilute nitric acid. So we know that this phenol is a weak acid which can react with sodium hydroxide and sodium metals. So therefore, when this phenol, which act as a weak acid, will react with sodium and it will produce the sodium phenoxide and the gas, hydrogen gas. Right. So this is a balanced equation. And another one is part 2. Draw the structure of two major isomeric organic products formed when phenol with dilute HNO3. So we know that the phenol group is 2,4 directing group, means whenever there is an electrophilic substitution, the phenol is the benzene ring activator, means it will activate benzene ring and it will direct, okay, this is 1, 2, 3, 4. So it will direct 2, 4 substitution. Means when there is a nitration, means when this phenol react with dilute nitric acid, so the nitro groups it will direct to this 2 and 4 position. So means it will be these two products, 2 nitrophenol and 4 nitrophenol. Part B, salicylic acid can be synthesized from the phenol, right, which shown here. So this is the group that added to the phenol. So remember, when there is a reactions between the phenol and the others reagent, in this question is CO2, you need to understand there is a new bonds formed between this C and the C in the COOH. So it means it's a new CC bonds form, right? Then when you draw the mechanism, then you know which way is attack, or what is the bonding that form, right? Okay, one of the steps in this synthesis is electrophilic substitution, reactions of carbon dioxide with the phenoxide ion. Complete the mechanism in the figure 9.3 for the reactions of the phenoxide with CO2. Include all the Curie arrows, dipoles, charges, and intermediate. First, and of course the most important one, you must know where the arrow point to. So for the electrophilic substitutions, we know that it's always the one arrow, okay, from the benzene ring, means the one of the pair of electrons from benzene ring needs to donate out to others. So this arrow must point to the partial positive charge species, or the positive site. So in this CO2, we know that oxygen is more electronegative, so it's a partial negative. So you need to put a partial negative charge here and partial positive charge on the carbon. So therefore, this lone pair, it will donate to this C and form new bonding. So this is how the thing works. You need to put one arrow from benzene ring point to this carbon, right? Because it's a new CC bond form. So after that, another one step you need to be careful is, once the new bonds form, means CC bonds form, because the carbon mostly is at 4 bonding, so one of this bond must break. So one of the pi bonds here must break, and this pair of electrons will move to the oxygen to form the oxide. Okay, so it means something like this, right? So it's from COO negative, right? Because this oxygen already gains the pair of electrons from the CO double bond just now. Okay, so this is intermediate. Again, when you draw this arrow and this dipole, you get 1 mark. And when you draw this correct intermediate, you get 1 mark. Another mark will be given when you draw this, the CH bond, and you draw one arrow from the CH bond, point to into the ring, to show that these electrons now is moving back to the benzene ring, to the ring, and restore the benzene ring. or we say that restore aromaticity. Okay, after that, of course, this one will form the hydrogen ion, right? Means the proton. So when you draw this arrow together with these products, so it's 1 mark. So total is 3 marks. Okay, part C. This question is not really that difficult. You just need to draw the correct curly arrows to show the bond formations and bond breaking. The products already shown, cyclohexene. So how to form cyclohexene from this buta 1,2-1,3-diene and ethene? It's quite easy. So first you need to put one arrow. Better we start from this buta 1,3-diene. So you need to draw one arrow from this double bond, point to this CC bond, right, to show the what I call the bond double bond formation here. And you need to draw another arrow from these double bonds point out. This one is to show that these electrons will move out and form new bonds with the carbon. Means this carbon will form new bond with this carbon. So if these new bonds form, means these double bonds need to break. So the pi bonds break. You need to put one arrow point to the other side to show that there is a new bond form between this carbon and this carbon. So therefore you get this cyclohexene. This is how the thing works. And of course, for the last part, you need to follow the same mechanism to predict the products. Okay, so because now we have these cyclic, so you need to do the same thing. Draw one. The arrow actually is flexible. Let's say now we draw this arrow from this double bond, right, to form this new CC double bond. Okay, and this of course these pi bonds need to break, and this electron move out and form a new bond, okay, between this carbon and this carbon. And of course, when it's formed new bond here, this pi bond need to break, and this electron move out, and it will form a new bond between this carbon and this carbon. Okay, so therefore it will form these products. Okay, that's all. Thank you.